Hello and welcome to this exercise on vector equations, and it's part 3 of uh, 3 so far. Please watch parts 1 and 2 as well. Now this uh, particular exercise was suggested to me by a subscriber, and, and it says the cuboid has coordinates as shown, and the coordinates are at H400, and at F we have 050, and at A we got 003, and at O, the origin, we have 000, as you would expect. Okay, it then says find vector FD and the length FD. So you're looking for the direction vector of FD, and to do that we need to find the coordinates at the point D, and we got 403 there. So those are the coordinates at the point D. And then to find the direction vector of FD, we subtract the respective coordinates of F from those at D. So we do 4 minus 0, 0 minus 5, and 3 minus 0. And we end up with 403. Sorry, we end up with 4 minus 5, 3. And then the length of FD, or the magnitude of FD, will be the squares of 4 and minus 5 and 3 squared, the square root of those anyway. So that will be the square root of the sums of 4 squared and minus 5 squared and 3 squared. And for that we get 50, and that's fine. You leave it at that. That's good enough. Okay, now for the third part, it says writes down the equation of the line FD in vector form. For that we get 050, because we move from, first find the position vector of F, which is 050, and then the direction vector of FD, which is 4 minus 5, 3. And of course for the equation we need to add this t there, because t will give you a variable there depending on the points on FD, or even FD extended. So hence t there. So the answer we require is 050 plus t times and the direction vector of FD, which is 4 minus 5 and 3. Okay, now for the third part, and that says P is a point on the line FD. Now FP is a quarter of FD. Find the position vector of P. Okay, now don't forget, from F to P is a quarter of FD. So to get to P, because we do not know the coordinates of P, to get to P we go from 0 to F and F to P. Now because FP is only a quarter of FD, we then replace this t here with a quarter. So we end up that the position vector of P will then be component 050 plus a fraction, in this case a quarter, of the direction vector 4 minus 5 and 3, the direction vector of FD there. So we end up with 1, 3 and 3/4, and 3/4 there. So that would be the vector position, the position vector of P. Right, and moving on from that to part 4, it says find the acute angle where OP intersects FD. So we want to find this angle there. Okay, now to do that, we need to use this formula here. Oh, sorry, I forgot to put. Now that formula gives us is equal to the cosine of the angle we're looking for. So that we cos theta there. Excuse me. Oops, sorry. So we got cos theta there. Okay, so the formula says the dot product of the direction vector of OP and the direction vector of FD, and that gives us cos theta. Okay, now moving on from that, so firstly we want to find the numerator, which is the direction vector OP, so the dot product of direction vector OP and direction vector FD, and for that we get minus 50 over 4. So in effect we multiply the respective x values there. So do 1 times 4, this 4 here for OP and this 4 there for FD. Okay, and similarly we do 3 3/4 there for OP and minus 5 there for FD, and so on. So we end up with the numerator being minus 50 divided by 4, and that's what we got. Okay, now for the denominator, this one here, we're looking for the product of the magnitude of OP and FD. So, and we get the answer, this one here. So looking for 1 squared plus 15 over 4 all squared plus 3 over 4 all squared, and the square root of that, will give us the magnitude of OP. Now, for calculation, to help myself, what I've done, instead of 4, I've got 4. Sorry, instead of 1, I've got 4 over 4, which is 1. Okay, 4 over 4, and this, if you square 4, sorry, if you square 4, it gets 16. So for this here, these 3 terms, each of these 3 terms has got 1 over 16 as the denominator. So a quarter, so the square root of 1 over 16 is a quarter. So a quarter is a fraction for all of these 3 terms there, after we've done the square root there. So we end up with the numerator, which is 50 over 4, this one here, numerator, divided by the denominator, which is this one here. So these 4's will cancel out. Okay, and the 5 here, because when you remove the square root sign there, 125 times 100, and the square root of 100 is 10. Now if you divide 50 by 10, you get 5.0, hence 5.0 there. Now this 5 will go. Okay, that goes. So now I got 1 over the square root of 5, and minus 1 divided by the square root of 5 will give us minus 0.4472, and that's the cosine of the angle 116.56. But we're looking for the acute angle, this acute angle there. So if we now subtract 116.56 from 180, we end up with 63.4 degrees. So this angle here is 63.4 degrees. Okay, as required. So now to part 5, I think. For part 5, it says find the coordinates of P prime when the length of OP is minimum, or where the length of OP is minimum there. Now, for OP to be minimum, the point at which OP intersects F, we call that P prime, the point at which OP intersects F, the angle there should be 90 degrees. Okay? And that's always at the midpoint of FD. And P prime would then be half of FD. So now, as we did earlier, where we replaced T with a quarter, in this instance, we're going to replace T with a half. So that then is the position vector of P prime. Yeah, that will be the position vector of P prime. Now we're looking for the coordinates of P prime. Now, this value here, or the values here, represent the direction vector of OP prime. But we're looking for coordinates. So we need to write this out in the normal manner for coordinates. So we write the coordinates of P prime then becomes 2, 2.5, and 1.5. Now, I hope all that made some sense, and please subscribe. And please watch Part 1 and 2 as well. Thank you for watching, and bye-bye now. Bye-bye.